Hey everyone, and thanks for tuning in again. In today's video, we'll be going over diagnostic plots. So we covered some of these diagnostic plots already in the checking regression assumptions video. We looked at scatter plots as well as histograms. However, that video was more conceptual and focused on how to identify violations to assumptions that are testable in our sample data. Now that we're familiar with what violations might look like in plots, this video lays out a practical approach for using plots as a diagnostic tool. What I'll show you in this video is a concise set of plots which give you the biggest bang for your buck. This approach is easy to implement in your data analysis workflow and should work well for any regression analysis as well as other analyses that are extensions of regression. For example, there's structural equation modeling, multi-level modeling, and factor analysis. As mentioned in class, remember that all assumptions are likely to be violated to some degree, especially in sample data. However, it is unreasonable to try to fix every single violation, and that shouldn't be the point. Many of us have lives and cannot spend an unlimited amount of time checking that assumptions are met or addressing assumptions that are violated. So a more reasonable goal is to provide evidence that the assumptions are not too badly violated or passable, and therefore the results of the analysis are likely to be unaffected. So there are two things. If there are no severe assumption violations, then you are able to proceed with running the analysis and interpreting the results as usual. But if there are severe assumption violations or evidence of severe violations to assumptions, then more work needs to be done. But at least it's clear where your efforts should be focused. So with that, let's go ahead and get started with the lab. Okay, so here I have SAS open, and then I have this file open that's available online called week9_template SAS. Now before we get into importing data, just remember that these lines here that I'm highlighting, this one right here, and then these two at the bottom, if you uncomment those by deleting the asterisk, so this one, and then these two, and then if you rerun all of this with all of the syntax that we'll write in this lab, it will export all of your output to a Word document. And so I've explained that a couple times already. I just want to make sure that you know what those lines are there for. Alright, so I'm going to comment them out. And again, this line here, and then these two lines down here. If you uncomment those at the end of writing out all your syntax and you run it, it will run all of the syntax that you've written, as well as output everything to a Word document. Alright, so let's get started. And first thing we'll do is we'll read in our data set. And remember that we'll be working with the Reg Data 3 data set once again. So we'll go to Import Data, tab Delimited File, click Next, Browse. And remember that I keep my data sets in the C drive in the Datasets folder. Nothing shows up because it's limited to .txt files, so I want to go ahead and select all files. And then here I have my regdata3 .dat file, or the tab delimited file. So I'll select that and click Open. Next, we'll name it regdata3, and then I'll click Finish. And then we'll take a look at our data set here. And again, we have X1, X2, Y1, Y2, and Y3. And remember that the numbers correspond to the model. So X1 and Y1 are in one model. X2 and Y2 are for a separate and different model. And then Y3 is just an extra criterion variable that we have that has no corresponding predictor. Okay, let's go ahead and click out of that. So let's go ahead and set our ODS to HTML. And then the first diagnostic plot, the one that'll give you the most bang for your buck, will be the scatter plot matrix with histograms on the diagonal. So to create this, we're going to use proc sg scatter, and our data are reg data 3. And then here I'm going to use the matrix statement, and I'm going to type in all of the variable names that I'm interested in plotting. And so in our case, it's all of them. So x1, x2, y1, y2, and y3. And then now I'm going to specify what I want on the diagonal. And so I want histograms. And then we can go ahead and run this. So up here you have the variable names, and then same thing down here on the columns here, I guess on the rows. And then you read it much like you would read a correlation matrix. So where each variable meets itself, so x1 with x1, x2 with x2, y1 with y1, we have histograms here that fall on the diagonal. And then on the off diagonal, we have scatter plots. So this is a nice, quick, and concise way to check if anything needs more paying attention to. So let's go ahead and start with the scatter plots. And so what we're looking for here is that there are no patterns, or for instance, something that we should be alerted to is x1 and y1 here. We have this megaphone shape, so we see that there's evidence of heteroscedasticity, where the distribution of y, or the variance of y, seems to be increasing as x increases. So if we look here at lower values of x, the values of y seem to be more tightly clustered, but out here where we're at higher values of x, y seems to be more dispersed. And that's how we get this what we call a megaphone shape, which again is evidence of heteroscedasticity. So maybe this is something that we want to take a deeper dive into to make sure that this won't be causing issues for our analysis. Okay, and then we can also check the histograms here. So if we look at the histograms, x2 looks okay, y2 looks pretty normal, but this one outlying point here is creating somewhat of a positive skew. And then y1 and y3 seem to be positively skewed, so that might be something to take note of. And then I think the worst of them is probably x1, which seems to be nowhere close to normal and is somewhat bimodal, but also could be just uniform. So, so just kind of a flat line across the top here. Kind of makes it look like it's uniform. Anyway, regardless of what the shape actually is, it doesn't look normal, so this is something that we definitely want to take a look at. Okay, so again, this scatter plot matrix with histograms on the diagonal is a really nice plot. It condenses a lot of information into just one figure. And so this is probably the most useful plot to take a look at when you are trying to run diagnostics from the get-go. All right. Next, we'll be looking at plots of residuals against raw scores of the predictor and then predicted scores. But to do that, we first need to estimate a model to obtain our predicted values and our residuals. So we'll go ahead and use proc reg. Our data set is reg data 3. And then in our model statement, as an example, we'll just focus on the model that predicts y1 from x1. So y1 predicted from x1. As we've been doing, I'll request standardized estimates but we don't really need to worry about that in this lab. And then I'm going to use this output statement to collect our our model predicted values as well as our residuals. So output, and then I want it to be outputted to our regdata3 data set. And P, so our predicted values, I want to call those pred. And then R, which are residuals, I want to call those resid. Now remember, this has to be P and this has to be R, and P refers to predicted values and R refers to residuals, and then these are just names that I've given them. So you can name it whatever you want, but here I've named it pred and I've named it resid. And then we can go ahead and run this. And then we'll get all of that output, but I'm not worried about that right now. I just want to create some diagnostic plots. So I'll go ahead and, now that we've estimated our model and collected our predicted values as well as our residual values, I can go into proc sgplot to create some scatter plots here. So again, we're going to be using regdata3, and then in the scatter statement, I'm going to specify that y is resid, which is the name I've given to my residuals, and then x is x1. So here I'm creating a scatter plot, and I'm plotting residuals on my y-axis, and then I'm plotting x1, so the raw values of x1 on my x-axis. So let's go ahead and run this. And here we have x1 plotted against our residuals. And again, we see that megaphone shape, which is evidence of heteroscedasticity. Okay. Now remember that plotting the residuals against the raw scores of the predictor or of predictors is a simpler sort of diagnostic plot. And so to get a plot that's a bit more telling, we can plot our residuals against our predicted scores. And so again, I'm going to go into sgplot. Our data set again is regdata3. And then in the scatter statement, I'm going to plot residuals on the y-axis, but this time on the x-axis, I'm going to plot my predicted values. Remember, these are the predicted values from the model predicting y1 from x1. All right, so I can go ahead and create this plot here. And then now we have predicted value of y1 plotted against the residual. And again, we get this megaphone shape, which is indicative of heteroscedasticity. Now again, these plots should look different under more complex models, but because we only have one predictor here, they're exactly the same. Although the x-axis does change, so you could see this goes from 0 to 50, this goes from 0 to 100. Which are the scales, which are the respective scales of x1, and then the scale of the predicted value of y1. Although those are different, the actual shape is exactly the same. And that's because this is a simple example where there's only one predictor. But remember, when you're doing this in practice, plotting the predicted values against the residuals offers a little bit more insight, while plotting the raw value of the predictors against the residual is more of a simple diagnostic plot. Okay, So we've created up here probably the most useful plot for diagnostics, which is our scatter plot matrix with histograms on the diagonal. And then we plotted some residual plots down here. One looking at the raw value of the predictor, and then one looking at predicted values that we collected from our regression model that predicts y1 from x1. And so with that, that concludes this video on diagnostic plots in SAS.